Page 39, the money mystery. This is the part for unraveling the trick. And I told you that this was fairly complex, so I'm going to go step by step through it. These highlighted instructions or step numbers the yellow ones refer to the steps that are in the book. So for step number 1, it says imagine a sum of money less than $10. So you tell the person to choose a number less than $10. And over here, algebraically, we're representing each digit that they have as X, Y, and Z. Even if some of the digits repeat, we don't know at this point. And in the instructions, it suggested that you make a place value chart. So they called it the units, the tenths, and the hundredths. The units is also called the ones place. The pink is an example of what's going on numerically, arithmetically, and the others obviously are the variables. So this is how we start. The next step does not relate to a step that is in your book. But what we need to do to get this to work out algebraically, so I highlighted these with orange, is we need to borrow 1 from the units column. In other words, from the ones column. So if we're taking away 1 from X, that is going to be X minus 1. Now remember, because we're dealing with decimals over here, when we take away 1, that is equal to 10 tenths, because this is the tenths column. So we're going to be representing that as 10. We're going to take 1 unit away, and that is equivalent to 10 tenths. So we're going to add that to Y, and we're going to leave Z alone. So in our example here, we're taking 1 from 6 and getting 5, and we would end up with 10 plus 4, we would end up with 14 tenths. And we would still have Z, or 2 hundredths here. We're going to do the same thing down here, but we're going to be borrowing from the tenths column. So we're going to leave the units, or the ones column, the same. So you can see I just brought down my 5. And I brought down my X minus 1. Over here, I'm going to be taking 1 away from this column. So that would make this a 9. And when I take 1 away from 14, I'm going to get 13. And again, when I'm taking 1 away, it's going to be 10 tenths. And so I'm going to be adding that over here. So now my Z becomes Z plus 10. And I have 2 plus 10. And so I have 12 in my example. Now I get back to the instructions in the book. Transpose the digits from the original number. So the original number was 642, or $6.42. Algebraically, it was XYZ. So we're going to transpose and bring the Z down here. The Y stays in the middle. The X goes at the end. And for my numbers, the 2 and the 6 trade places, but the 4 stays in the middle. Then the instructions ask you to take the difference between this one and number 2. So we're going to take the difference between x minus 1 and z, which would give me x minus 1 minus z. When I look at my example, it's 5 minus 2, which gives me 3. I'm going to do the same thing all along here. I'm going to be taking the difference, so y plus 9 minus y is y plus 9 minus y, and that simplifies to 9 because these two y's cancel each other out. Additive inverse at work there. Subtracting here, I'm going to be taking 12 minus 6, and I'm going to get 6. And when I take z plus 10 minus x, I get z plus 10 minus x, and I cannot simplify that any further. Next part, write in expanded notation. So what that wants us to do is to take the place value representation and the algebraic representation and write down what this actually would be, because so far we haven't accounted for the place value here. So at this point we're saying, well, this isn't really 9, it's 1/10 times 9. This isn't really z, it's 100th times z, plus 100th times 10, minus 100th times x. So we're writing it out with the expanded notation. And when I do that with the number, I have 1 times 3, and I have 1/10 times 9, and I have 100th times 6. My next step asks me to transpose the expanded notation, but on this one I'm going to leave the place value notation. So I'm going to leave the 1 and the 1/10 and the 100th, and I'm going to take the z plus 10 minus x and bring it down here to the inside the parentheses and leave 1 outside of it. Of course, my 9 just stays. And then I'm going to take the x minus 1 minus z and put it with my times 100th. Then I'm going to find the sum of 3 and 4, or excuse me, c and 4. So that is this expression plus this expression will give me 1 times the quantity x minus 1 minus z plus 10 minus x. And then here I'm going to have 1/10 times 9 plus 9 because I'm adding these. And then my last one, I'm going to be taking 100th times the quantity z plus 10 minus x plus x minus 1 minus z. And you'll notice that when I do that with my numbers that I had, I have 3 and 6, and that's going to give me 9. And over here I have 9/10. 1/10 times 9 is 9/10, and 1/10 times 9 is 9/10, and that's going to give me 18/10, which is equivalent to 1 and 8/10. And over here I have 100th times the quantity z plus 10 minus x plus x minus 1 minus z which ends up simplifying to 1/100th excuse me. The pink, I'm getting confused here. The pink is 6 plus 3 is 9, and that's times 1/100th. So that's 9/100ths, which is equivalent to 0.09. So right here you can see I'm going to have a lot of things that are going to cancel out. My x's are going to cancel, my z's are going to cancel, and I'm going to be left with -1 and 10. Right here when I added, I got the 18. And over here my z's are going to cancel, my x's are going to cancel, and I'm left with 10 minus 1. So on the next page, we're almost done. We're going to simplify, which I just did, and we're going to announce the answer, because 9 plus 1 8/10 plus 9/100ths is $10.89. And that is a heck of a lot of complicated algebra to demonstrate why this works. Thank you for stopping in today.